one more and we will start. Okay. Amir, you ready?
Hope so. It's up to everybody to say if it was good or not. So, in my side, I'm ready.
Okay. Thank you all for joining to this session. It will be a bit different than previous ones that we did. But when I spoke with Amir recently, I was thinking, wow, this is a totally different view about what's happening with AI in the industry. So I'm glad you joined to hear the story as well. Just a few words about a community. I've been building several communities and for the past 10 years, and this one is more focused on AI. We have many people from the US, different leaders in different organizations. We have WhatsApp group. I'm not sure if everyone here are in the WhatsApp groups, so please feel free to join. I will send in a second the link to the new website that Claude created recently. So please let me know any feedback about the sign-up process if you join. Also, please invite other people as well to join the community. And we're also looking for more speakers to come up and present your work, or if you know someone that might be relevant to the community, please let me know as well. Your feedback is really important. So this is how we can improve, bring more interesting speakers to the community and learn from each other. So I really appreciate if you will reach out, send me an email, WhatsApp, whatever works for you. So thank you, Amir. I will let Amir to introduce himself and his work. And I'm really looking forward to hear a story as well. So thank you, Amir.
Sure. So, really nice to be here, and thank you for inviting me, Boaz, and to try to share our perspective on the big industry or the big thing that's called AI. I'm the CEO of DCX. This is an engineering company that lead and develop major data centers in, let's say, in all the sectors, from finance, security facilities, and AI facilities. And our angle or approach is from the engineering and our challenging in this environment that's called data centers, and not as consumers of those facilities. Now, usually, just a second, we'll try to pick. So usually, this is the agenda, but I will continue talking if it's okay. So usually, when all of the general population or all of us as a people ask ourselves what is AI or what is data centers, it's like a big loophole of major things that impact in the end all of us. And I will try to touch in this discussion and how what is the market, how it's looking from our angle as building those facilities, or what our challenges are. What is the component of form of those facilities, and try to touch a bit of what is AI from the infrastructure and not from the application. So I would like to start in let's say small point for thought. Okay, Jules Verne in 8070 wrote 200,000 miles under the sea. He was really great thinker or imaginer of things, and let's put it in our head. So the global trends from 2024 until today, we see huge change of what is data center, how data centers change, or what are the vacancy or the capacity that we need to provide for those facilities. Just for example, every 1 megawatt is something like 2,000 to 3,000 houses in the US, because in the US we like to consume more energy. So we need to understand that when we talk about 6.2 gigawatts operation in 2024, it's a lot of houses and it's a lot of energy. Today, challenging, we're going to peak to almost 250 gigawatts until 2029 in our perspective. So the demand of energy or the demand of growth totally, let's say, coming from the AI needs, okay? Because the clouds, we don't see a lot of change in 2025 to 2026, but the work that all of you guys doing probably just push the energy demand and data center demands to the limit. And why to the limit? We will see in a second. When we're looking on data centers, or what is the flow of, this is like a bit more zooming of how the regions look like. We see that only 13 gigawatts from the 25 gigawatts is for colocation, and 12 gigawatt is for hyperscale. So that's mean that Google Cloud, Azure, AWS, and etc. This was the demand. Today we can see that we have 111 gigawatt in planning of colocation. Colocation, in other words, it's now clouds, and I will expand a bit later what are the difference between those. From our perspective, all of the demand of the neo clouds are, as we're looking at, as colocation and not as hyperscale, because in the end they're selling the capabilities to the hyperscaler. So for us, 111 gigawatt is for the AI neo clouds demand. When we look on how we're going to develop data center, we need to understand that the most important thing is power. If we don't have any power, or let's say vacancy in power, we can't build those facilities. Today, the smallest facility that in the new age that we're trying to touch is 100 megawatt, up to 2 gigawatt sites. And we can see that every, let's say, 2 weeks, there is a new announcement of 10 billion or 10 gigawatt of new AI company that's going to do neo clouds and support the new models, and the capacity just continue growing. If we develop until, let's say, 2 years ago, with the biggest sites that was developing in the world, let's say, for most of the sites was something like 50 megawatt. Today, most of the sites is between 200 to half a gigawatt of capacity, of IT capacity in the end. Because when we look on energy, when we look on, we'll go to this slide in a second, but when we look on energy and we look on how we calculate those demands in try to transform it to the IT of the data center, we need to multiply that by the PUE. It's power usage efficiency. So it's mean that if I would need to give 100 megawatt of demand of IT demand, I need to build a data center something like 140 megawatt of site. Now, so we need to start from the power. Today, the power in the world, and we will see it soon, is getting. We have like really difficult task to get those power, to have the right power to the sites. So we try to push from different kind of places and build in new regions, and not in the traditional ways. Usually, to build a data center is something like 26 months, 18 months of build, and another 6 to 8 to develop and find the right place to build in. Now we can see that most of the data centers that build today have pre-lease rates before the build start. So if you're hearing about new demands, it's mean that nobody taking care of it yet. So our problem or our challenge is how we're going to deliver those facilities today, and how we're going to continue develop under lack of power and land. Now, in the US, land is very easy. In Europe and other regions, it's very difficult to have those lands because we need significant size of land. Today, the smallest plot that we need is between 25 to 50 acre per site because of a lot of the component that we need in those data centers. And if we will try to understand what is the if there is any question, Buzz, and if you want to stop me, tell me. Okay, I'm trying to go on the slide, but if there is, then just tell me. So if we try to see what are the components that we have in those data centers, so data center has to be in the SLA of data center is 100%. Now we can't develop or design for 100%. We can design for 99.99 something percent of SLA from our design side, because in the end you always have some component in the way that will be manufactured. So we have generators, and we will have a generator in the future, because at the end we need a backup, a local backup. We have switchboards, UPSs, a lot of cooling capabilities. The cooling is changed between using water or not using. We will see it as the next challenge in those data centers, and I will talk about it soon. And we have all the other components that support the IT hall, the data center itself. From standard view, when we look on topologies of how we can maintain those data centers, and we have some like try to visual what is the tier or what is the tier. The tier is I'm sure that everybody familiar on tier 3, tier 4. The tier perspective coming from maintenance. As we go into from tier 1 to tier 4, it's mean how much we need to invest in those data centers, and what is the, let's say, the capabilities of the redundant in those sites. Now, usually data centers are between 3 years plus.
I wanted to let you finish. So just when you finish, I will ask the two questions.
So most of the data centers are between tier 3 to tier 4. Sorry. Between tier 3 to tier 4. Because the demand of the mid is to have the 99.99 something. Nobody want to live in a shed, and everybody want to live in a Versailles Palace. But usually they see as the palace or the right fortress as good enough, and we need to comply with those demands. Today, we don't see any hyperscaler going to tier 4 because it's too expensive. It's cost something like between 15 to 25% more from the energy system side. So usually they're stuck in the right fortress. Yes, boss.
One question was about at least we see many LLM moving into a local model. So do you see any changes in how hyperscalers are modeling the demand? That was one question. The second one was the firmware planning. Is local pushback actually reshaping where and whether you build, or is mostly media noise? That was the second one, and we have third question about how do you the DC distribution moving forward? There is some techs in the industry to have smaller DC distributed close the customers.
When we have we try for we start from the last one because it's connected to the first one. So when we look and try to talk with the hyperscalers and to try to understand the models, we see that because of the highly connectivities in those data centers, for now we don't see any edge data centers developed. So we will not see smaller data centers like before, and we will see the LLMs will go and going to build in big facilities because they need the right connection between the big seven. Okay, Oracle support Microsoft and support Google, AWS does it working, let's say, doing their own things, but in the end, they have to be connected. The issue is today the communication is something like 10% from the cost in those data centers, not the GPUs on the other hardware. So when they build large data center, they have or small data center, the 10% become more than like 40% because the equipment is very expensive. So they need to not to have it centralized and not like far away from each other. Today, let's say NVIDIA, and you can see it in NVIDIA models of data centers, not models. They have connectivity of 250 meters, let's say 800 yard between the core to the farthest GPU. So they have to be very close to each other. So if we build smaller facility, it will not be cost efficient. From the regulation vector or power demand, I have 3 slides in let's say 10 minutes, and then we'll work on over there. Okay. So yeah.
What about actually like local models? So even enterprise, they can run some inference locally. Is this something that you see a trend that the consumption somehow got affected by like local models or this?
Maybe we will see it. I will try to explain in a few slides what is the challenging with the direct cooling and what is the system that we need to support to have the right cooling for those sites. Usually local model, it's very to build a local data center, small data center, it's very expensive from the infrastructure side because you need to build and push a lot more money to the infrastructure. It will not be so efficient from the equipment side because we check it. The reason is we're changing the cooling systems and the approach of those systems for that. Okay. And again, I will try to explain what our challenges in a few slides. I hope it will be answered for a bit more wider, let's say. So, as you said, colocation facilities, hyperscale cloud facilities, and AI. Sorry, the Apple mouse, it's really nice, but it's have its own life. Okay, not only the AI. So if the slide go back and forth, it's not me, it's the mouse. So when we try to see what is the sizing of those data centers, we can see that if we have regular colocation site, let's say until 2025, 2024, let's say, most of the data center was between colocation facility sizing to the hyperscale cloud facilities. We had something like roughly of 50,000 square feet with 1,600 to 2,000 racks and approximately 6 kilowatt per rack. Again, it's the average. Of course, we had like 40 kilowatt per rack, but most of the market was between 1.5 kilowatt to 3. So 6 average was the planning point for most of the data centers in the world. In 2026, it changed. So if in 2024 we have 50,000 square foot net per 10 megawatts, today we have 5,000 square net for the same 10 megawatts. All the sizing is completely changed. The the challenging is how you can define from what is looking today as an AI or as a build site of 10 megawatts, one going to be the future. So I will talk, and we'll see it in a second. So today, 600 megawatt IT, it's approximately of 100 megawatt of power. Again, 100 megawatt of power, roughly 40,000 houses of electricity every day. And it's only in 40,000 square feet net. The plot is much more higher. We can see it's something like 60, 65 acres. But in the end, this is how we look and as a regular or normal data center today. That
Amir, can you explain the numbers?
Sure. What are the numbers? The square feet or the energy or those partial of all of the numbers?
Try to explain to someone that is not in the area.
When we build a data center, we have a net or gross. Okay, in the end, 80% or 90% from the data centers today are going to the gray space. When we said gray space, we're talking about generators, cooling systems, pumping, transformers, UPSs, switchboards, cable routing, bus bars, and all of the infrastructure that you need to drive those racks. When in the end, we need to supply the demand for the rack. Okay, so all the infrastructure need to be routing in the best way to the end single rack. Mm-hmm. So today we can, when we see I would explain it over here. Okay, explain it over here and we come back. So as we let's say driving through to the future and having better gear, let's say from the GPU side, from NVIDIA and other let's say provider, we can see that the energy or the consumption per compute per rack is completely changing, but in the end, we need to support them from the same source. So our challenge is always to see how we can support the rack from and the change of the rack from the single point of GPU. And this is the problem that I tried to explain before. If we build a data center in-house, we need to support the same systems, and it's very complex systems, very expensive systems for a rack or two. Okay, and from the LLMs side, it's like you don't need much more than 2-3 racks to have the right size of in-train or to understand what is your model. So that's why usually we don't see it those kind of build in housing or let's say in companies. We see it part of pretty big systems. So if let's say I want to support today Blackwell Ultra 150 kilowatt per rack, this is the support point that we see today as the B300, as everybody knows. We need to support it from 150 kilowatts per rack. Going back, it means that in the single rack that we can see over here, each rack is between 80 kilowatt to 150 kilowatt gross. Why 80? Because of the communication. Now, this is one of the first challenge, how you can push a lot of energy and a lot of water flow or all other kind of cooling options to really small and compact room. This is our first challenge. The second challenge is today, and the number are changing. It's not 70-30, it's 80-20 or 85-15. It means that on each kilowatt of data center that working in direct cooling, and I will explain what is a direct cooling in 3 more slides. In each kilowatt in direct cooling, we need between 0.3 kilowatt to 0.15 kilowatt of air cooled. And air cooling, it's not so efficient. And this is one of our challenges, and we talk about in the challenges slide. In the
I want to comment. Earlier today, I had a call with someone from the largest banks in the US, and they told me like AI consumption got to almost like $1 billion just in in a few departments. So basically, like for them to go and build their own data center, it's like a huge issue with probably versus continue to pay the LLM consumption costs that they're paying today. So like when it will be.
What is the sweet point? What is the sweet point to do it in campus or to rent it, right? So there is not right number. I can try to calculate it, but the problem, and we can see that, let's go 5 years ago, IBM had their own data center, HP had their own data centers, Google, Microsoft, and everybody had their own. Okay, and when and 5 years ago, everybody dropped it, and all of the market begin list, and they listed because they didn't have any other choice, and they didn't know how to maintain it good. And those facilities was very old, most of them. And even the new one, they sold them because it wasn't apart from the financial model. Now let's say the power consumption going to be the same between big to be hosted in one of those facilities, and the GPU probably will be more expensive, not cheaper, because the DOR or the force with the GPUs today are very high. It's something like 6%, and it costs a lot of money to buy those. And the life cycle of those equipment to be up to date is between 3 to 5 years. Even if we see that everybody read that the Trump approved to sell China H100. It's like old model of NVIDIA product. Actually, the H100 was classic and very easy to maintain in data centers. Okay, the new ones are more challenging because the heat sink and the change between the approach of how we're going to maintain it, it's completely different. Today, we need more plumbers than AI programmers. Okay, it's like this is our issue, and from that perspective, I think to build by yourself, you will have a lot of more, let's say, more of your cost of download will be much significant than rent, because every time that you push a new equipment, it's going to be challenging. When NVIDIA in their laboratories, actually they are in Israel. Okay, most of us from over here is from Israel. So in Israel, we have the most technology laboratory of NVIDIA in the world. All of the new equipment, it's going into those that facilities next to Haifa, and they tried it out, and the cost of maintaining it, it's like double than maintaining a regular data center, because it's different kind of population and a different kind of working balance. Okay, so I don't really know if in the future it will change and it will be much more efficient to build your own. Today, that most of the market is NVIDIA based, it's much more expensive, and we don't see it changing today. There is a new GPUs, they are going to be released soon from other companies that we're going to see it. It's going to drive a big change. Maybe this conversation will be, my answer will be different in a year, but for now, I don't see any change for now. Okay, and it's not mean that to do it on-prem, if you know how to do it. The issue is not if you know or not know how you're doing it. It's how much capacity you're talking about. Okay. If you have 10 megawatts or 20 megawatt of equipment that you rent in the end or using um, from different kind of neocloud, so it will not be cheaper to do it by yourself for now. Okay, I'm sure it's going to change, but for now it's very expensive, too expensive. Um, and again, back to NVIDIA. Now, NVIDIA talking about how they're going to maintain 1.1 megawatt per rack. Okay, so let's try to remember 5 years ago, 6 kilowatt per rack average. 3 years from today, we're going to be 1.1 megawatt per rack. So it's like every 800 racks from 6 years ago, going to be one rack in 2 years ago, 2 years from now. So the perspective of how I'm going to maintain this challenge is unsolved. There is a lot of way to design those data centers better as blocks and be ready for the next step, but it's very challenging for us. I was talking liters, okay, and not in other measure and other proportion of measure, but every second we need to push 3 liters in a rack. Every second. So we need today, and we are in that stage, okay? So we need really big pipes to the racks. And now if you're going to have one rack that's going to be 1 megawatt, it's like more the triple or more. And in all of that, it's because of the direct cooling. Now, I don't know how many people know the old ways to the new ways. So I try to explain what we had until today, now it's how it's looking today. Until 3 years ago, we used only air as cooling method. It's mean that if you can see the house over here, the cold air came from beneath of the floor or in the space, pushed into the rack into the server. Those are the GPUs or CPUs. Okay, the air just passed against of the cooling lines, and we had a sink that saw 38 Celsius of heat. Okay, so it means that over here in this area we had 20 degrees of heat Celsius, and under the chip in the chip we saw 38 degrees. When we change it to direct cooling, we cooling directly the chip to 38 degree. It means that in the end we need 38 degree of water. Now 38 degree of water, it's not cooling anymore. It's like open flow from your sink, and that's it. So we can use regular cooling water, and we don't have those challenges as before. So we are much more efficient. The problem is what we're going to do from the other between 30 to 15% of air. So it's mean that every 100 megawatt, and now I'm talking 100 megawatts, okay, because this is the right sizing that we're working today. Every 100 megawatt of data center of IT capacity, it's 85 megawatt of direct cooling, like that. It's very efficient. And the rest of the 15 to 30 megawatts, we need to do it like traditional way, in the traditional way. Now, it sounds very, 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 very good and very, very, let's say, easy, but our problem is that the capacity of those 15% is the 100 capacity of data center until 3 years ago. So it means that in the end, we have much higher PUE and we have much higher, let's say average worldwide, okay, not like as a single site. A PUE, power usage efficiency. Our efficient, we don't really more efficient. We're more efficient per megawatt, but we're not more efficient to the world. This is most of the issues that we see today in the world. It's from the environmental side. Uh, what is the damage or what is the issue with those data centers? And now I will come back to the first question that you asked me. If we had more data centers, smaller ones, they're going to be in different places, and we build our own, it will be less efficient from that, and the consumption of energy will be much higher. So regulatories, the regulation will not give us to do that. It will be much more bad for the environment in there. And I'm just have to say that every new technology that we're using in already, we used it in the past. IBM did direct liquid cooling to the chip in 1988 with cold plates, as you saw in the last slide. Cray 2, 1985, did it with immersion. It means that you just dip all of your GPUs to the fluent and working like that. So we don't see anything new. We just see it in a different kind of implementation. Now, the consumption of the energy is coming, and I forgot that we were talking about over here. Let's say our first problem that all of us like gadgets, and we all of us try to make the world better, but in the end, every generate of a picture that I'm sure that everybody of you guys do it every day because it's fun or we need it. Every generate of a picture is something like charging your phone from 0 to 100 in a single action. Okay, so those LLMs and those sites and those applications consuming a lot of energy, and they're consuming more and more energy every day. So it's not a bubble because in the end we need those energies, and we use it every day in our life now. But the biggest question is if it's going to stay inside of those companies, or it's going to be with the different companies, and when it's going to, and where it's going to build or be. And it's usually because of those key concerns: power availability, land availability, operational market size. If it's worthy to build, we have enough people to maintain it. Or let's say Norway or Finland, it's like the best place to build data center, okay? Because it's good, it's very nice. It doesn't have enough energy anymore. The land availability in next to the major cities, we don't have it anymore. Today we started to build a campus of 2 gigawatts that have his own hotel, okay, because we need to fly people in and out to maintain those data centers, because we don't have enough people that live in around it to maintain it. So you can find the solutions, but they're good or not. It's like this is our issues today, and you can see it in the demand. In the end, Virginia doesn't have any power anymore. Okay, don't live in Virginia. Your power bill going up. I saw that there is one guy over here from Kansas City, right? So Kansas City is the next place they're going to build data center in. Like, yeah, you have more than 45 data center over there. You have another 3 gigawatt in the next 2 years going to build in Kansas City.
Why is that? Like, why Virginia and Kansas City?
We just why Virginia and Kansas City? It's two different answers. Virginia was the heart of the internet in the end. There is a lot of let's say conspirative rumors about why in Virginia, but Some of them is because the head of the FBI, NSA, and CIA is over there, but maybe it's because of that and maybe not. But most of the traditional data center was in Virginia, the best location-based connectivity still over there. And the energy start to move. They start in Texas, that everybody read about OpenAI and developing in Texas. It was like huge issue over there. And it's moved to Ohio, West Virginia, Kansas, Missouri, because of power price. You need to have cheap, but it's not cheap anymore. But you need to have it in better pricing, let's say, and because you have the right regulation to do that. Our issue is to find the right way or right place to build in. Now, Kansas City was targeted 2 years ago, and today we see massive deployment with Google, Nebius, as he said. We just heard that Microsoft bought really big plot over there, and we started to see that all of the energy in Meta have a massive to value, right? We started to see that we don't have enough capacity in Kansas City anymore. And what's going to happen? In Texas, the power price, the end user price was 30% more than 2 years ago because of those data centers. In the end, the local grid provider, those are private companies, not like other places in the world, and they're selling to the highest bidder. They don't have any means to stop doing that. So the price of the electricity going up. So this is our first concern. Now, a nice lady for all of us, so not so for data centers. Erin Bogovich, everybody saw the film, right? So the next protest or the next issue that he started to fight in is data centers. It's bad for, say, power sustainability. It's not clean. Microclimate. Okay, when you build 2 gigawatt site, the plants are changing. You don't have the same atmosphere. Okay, the humidity is changing in the air, in that area. Okay, not, let's say, not in all of the country. Yeah, but we see a lot of impacts that actually noise. It's not an issue, but she's saying it's noisy. It's not so noisy. I prefer that than a mall. Okay, but we see as those issues are real. So in our perspective, in the future, we will see a lot more behind the meter sites. Today, we know a lot of entrepreneurs or data center companies that and it's like between, let's say, between the open news that you can see that Meta built their own reactor, Boibos built his own reactor to have 10 gigawatt of data center in clean energy on nuclear reactor power plants. So we see a lot of people starting to develop gas wells and building their own power plants on natural gas, just not to take power from the grid, because we see that, let's say in New Jersey, we have 1.05 gigawatt of data center in the country, and limited for 1.35. So we have another 300 megawatt of data centers go to build in New Jersey, because the country stopped develop data centers because they don't have enough grid for that. And they need to reserve it as a country, not as a provider. So we see a lot of things going to change. So we're trying to understand those issues. There is a lot of countries that we still be able to develop really good sites, and we need it, unfortunately. And nobody can go back working without cloud, right? Everybody needs ChatGPT or Gemini. Nobody knows to work differently now. So we will continue consuming that and we continue using that. Uh, and completely agree that they're not using India. So if when it's going to develop to the next steps, and I will try to be positive, okay? As long as we're going to grow using much more energy for those data centers, the equipment will be must change and be more efficient. The data center will not change, but we can see that in, let's say, if you're taking the Google GPUs, and I already don't remember the name of the equipment. Okay, so I'm sorry. The Google GPUs or the NVIDIA GPUs as a product, you see a huge difference from the power consumption side. Huge difference, 40% different in the end. And it's a lot of energy. So if we can imagine that in the future we can cut it by half, we would use the same infrastructure on those data centers, but we will be much more efficient. So we can grow in GPU capabilities double in the
Google
same infrastructure.
Google sell their TPUs
CPU.
to other companies, or did they
You
just
know, we know it's in the plan. Everybody know it's in the plan. I think there is one transaction with Musk that he's going to do that, but not for now. Grok as well, right? But the consumption of Grok is like NVIDIA, so it's not really matter. We're trying to see what's going to be happening with CPU now. We try to go to see and understand if you're going to be 100% direct cool, and again, it's much more efficient environmentally from not direct cool. So this is our issues. The next issues is the cost of downtime. Let's say 40%. It's a survey of uptime. Yes, sorry, boss.
Amir, we have like 10 minutes, so maybe we can have like 5 more minutes, and then keep 5 minutes for questions, and show some numbers. I think the numbers about investments and
I didn't. Sorry, I didn't do that, but I can talk about it. It's not a problem. Every 100 megawatts of data center cost roughly of $1 billion to build. Okay, this is the number, between 6 to 7 million to the equipment, between 4 to 3 million for land and build. So it's something like $10 million per megawatt, $1 billion per site. And imagine that you see that I have a client that I just built, and we're just building 564 megawatt site. So you can imagine how much money they need to bring from home. So it's like a 5 billion project, and every project is like that. That's why when you want to build 10 megawatts of IT back home, let's say in your office, you don't have $100 million to doing that. Is the infrastructure. It's bid out to run it, maintain it, and pay on the electricity. So sometimes LLMs is more cheaper. It's still, there is not the right number. Never mind. I will send the slides, everybody. What are problems in data centers? So what are risks? So usually we have the man side, the people side of threat, and the regular side of like people. In the middle, we can see what happened in the Emirates like 1 year ago, that Iran bombed Amazon site. 3 sites was direct hit. Was like $500 million of damage from the right side. Sorry. And the left side is something that we work in every place. Let's say in Texas, we built in let's say very light facilities. In Kansas, we built with the concrete, because Dorothy, we don't want her to fly again, right? So we try to build in the right building materials in the region and out of the region, It depends what are the threats. Now, if we want to build a facility with all of these metrics, it will not cost $1 billion per megawatt, per gigawatt, per 100 megawatt. It will cost something like $3 billion per 100 megawatt. So that's why nobody invests in the right side. Okay, except of cyber, I think, but usually it's like that. Now, to build faster, we using as a trend with very let's say prefab equipment. It means that we manufacture a data center component in Europe, in Canada, in the US, deliver them and build them on site. It's reducing us, let's say, 40% of the time, because to build to larger site taking a lot of time. And if you want, let's say I have a project in Israel. 2.5 years ago, we finished a data center of 10 megawatts, not prefab, in 13 months. It was the fastest data center was built in Israel. Today, we're going to finish 140 megawatt site in 16 months because we're using prefab. If we were not using that, we would not be able to support it and deliver it at the right time. The last slide, I'm going to return to the first slide. Okay, Jules Verne thought about some things in the start. Okay, but you guys are responsible for one of each, or one of those scenarios. Everybody can choose by himself which scenario is responsible at. If you're going to be batteries in the future, or you're going to develop the next Arnold Schwarzenegger, but in the end, unfortunately, I'm supporting that. So please choose wisely. Okay. Now, Buzz, questions.
I'm just thinking, you mentioned one image, it's 0 to 100 phone charge. I'm just thinking about using Fabel 5 and running agents at scale. This is
yeah, it's scaring, guys. We're using a lot of energy. We have to have the right jump for the next steps. I'm working with several startups that are trying to find the right solution for the downtime of the data centers, because the data center doesn't work 24 hours. The right thing to do is to find a way to use 100% from those data centers, and not like today. Today, data centers are consuming 60% average energy load, because the company doesn't implement all of the capabilities in the same data center. They want redundant. We need to find a way to use 100%, because this is the right thing to do environmentally and efficiency. It will bring us more efficient.
Itai was asking, what are the main failure points in data centers? What fails the most?
Like we suffer in our small area, power blocks. Until a few years ago, and we have generated that backup in that, but every megawatt consuming 540 liter per hour of diesel. So when we build 10 megawatt, 20, 40 megawatt of the 50 megawatt of data center, it's only 2,000, it's only 25,000 liters per hour. So let's say if we have major block like we had over here for 30 or 40 hours, you have to have really big storage. Let's say until 50 megawatts, it's manageable. 200 megawatt, 300 megawatt, it's more, it's too massive. We can't store it. So electricity failure, this is the first issue. The second one is and we try to solve it today. There is not good answer in the world. It's the frequency of the AI load. It's sometimes too fast, and there is like a termination called spiky loads. So we have a lot of spikes. The model will go up and down very fast, and it's very difficult for the equipment to work like that. It's look like a power circuit, like failure circuit. So this is the second thing that we see as a big issue. But usually it's very reliable. We hope so. Yeah. No, it's very reliable. Yeah.
Agam is asking if you were deploying fresh capital today, which layer would you back first? Power generation, grid services, cooling, prefab builds, chip adjacent infrastructure, or data centers operators, and which would you avoid?
Today we don't have enough of operation companies in to support those things. It wasn't a mistake when Jensen said that the most important job in the future going to be plumbers. We need more capability to maintain those data centers because they are growing too fast, and we don't have enough of manpower to doing that, and robots are not there yet. Okay. Yeah, it's good money, right? I hope so.
Anyone else? No. Did I miss any question? Do you want to ask?
It's data center is right name. For what?
Like AI inference centers.
Inference factory. Data center that is a factory. It's right. It wasn't in the past. There is like AI factory, but AI factory means something else. Inference factory is good name, but it's a figure of speech today, right? It's the right super glue. So I think it's going to stay like that. Guys, it was a pleasure to try to talk and expand my perspective. If you have any other questions, just we're happy to.
Thank you so much, Amir, for your time and the presentation. It was for me eye-opening. So thank you again. Thank you for joining.
Thank you. Nice to meet you. Have a good Shabbat. Shabbat Shalom. Bye-bye.
Thank you. Shabbat Shalom.